Hello dear students, in this video we will understand how acceleration due to gravity varies with depth as we go down from the surface of earth. Okay, say this is earth. Okay, mass of the earth I take it as me. Okay, and I have considered a body of mass m at a depth d from the surface of earth. So this depth is d. Okay, now what is the force between earth and that mass? So we have to see what is the force between earth and that mass. If the mass is completely outside, then while calculating the gravitational force, we have to consider the mass of the entire earth. Okay, just to go through shell theorems once. Okay, now this mass is inside the earth. Okay, we have studied that in shell theorem. Okay, if the body is inside the shell, gravitational force is zero. Okay, now what you can do, you imagine a shell like this. Okay, now this is a shell. Okay, red color shell. Okay, for all the shells inside, okay, for all the shells within this red colored shell, this mass is outside, correct now? So all those shells will exert force. If you imagine cells here outside this red shell, okay, for all those shells including this outer one, okay, this mass is inside. So what happens, um, see, these shells, the shells present over here, okay, for these shells, this mass is inside, correct now? So therefore all those shells present over here, okay, they don't exert gravitational force on this mass m. So we have to consider mass of this sphere only. We have to consider mass of this sphere only. Okay, I take mass of that sphere, mass of this sphere as ms. Okay, mass of that sphere is ms. Okay, so therefore gravitational force between this mass and the earth, or mass of this sphere is, or I'll write f of d, force at that depth, is equal to g into m1. m1 means I should write mass of that sphere, not mass of the earth, because entire earth is not exerting gravitational force, into mass of the body divided by square of the distance. What is this distance? Okay, radius of the earth is re, correct na? Radius of the earth is re. So therefore this distance will be re minus d. Hope you can understand. Re minus d. So what happens? Divided by re minus d whole square. So this equation we have written according to universal law of gravitation. So what this equation we have written according to universal law of gravitation. Then according to Newton's second law, we can write F is equal to m into a. A means acceleration due to gravity at that depth. Okay, g. F is equal to m into g. So this is my equation number 2. So using 1 and 2, what I can write? Using 1 and 2, I can write. So what happens? This should be equated with this, correct now? M into g of d is equal to g into ms into m divided by re minus d whole square. This m and m gets cancelled. Okay, m and m gets cancelled. gd is equal to g into ms divided by re minus d whole square. Now what we have to do? We have to compare this gd with the acceleration due to gravity on the surface of earth. Like variation of g with the height we have studied. We have written g of h is equal to g into, correct now? G into 1 minus 2h by re. That g should come. What is the value of g? G is equal to gm by r square, correct now? Gm by r square. G is equal to gme by re square, correct now? We have taken this re outside. Now here in this derivation, I can take this re outside. I will get re square, but here me I am not getting. So therefore, what I should do? I should write ms in terms of me. So this is very important. Okay, this is very important. What I should do is, okay. So while doing the derivation, you should do this calculation on the right side. Okay. What we have to do is we have to consider this Earth having uniform density. Actually, density of Earth is not uniform, but here we are doing some approximation. If the Earth has uniform density, then what happens? Density of Earth is equal to density of this sphere. We'll take. Okay. So density means what? Density means mass by volume. Mass of the Earth divided by volume of Earth. Volume of Earth, what is the formula? 4 by 3 pi Re cube. Correct now. That is equal to, what is density of the sphere? Density of the sphere is equal to mass of the sphere divided by volume of the sphere. 4 by 3 pi Re minus d whole cube. Because what is the radius of the sphere? Re minus d whole cube. So now I got an equation for ms. So what is the equation for ms? See, 4 by 3 pi, 4 by 3 pi gets cancelled. Correct now. So ms is equal to this Re minus d whole cube goes here. Re minus d whole cube, Re minus d whole cube into me. Correct now. Me is there in the numerator. Divided by Re cube. So I got the value of ms in terms of me. Okay, this I'm going to substitute there in the place of ms. Okay, so what happens? GD is equal to, this is very important step, GD is equal to G divided by Re minus d whole square. I'll write it here into ms is there. Now in the place of ms, I'll substitute that equation. What happens? Re minus d whole cube, okay, into me I'll write here. Correct now. I can write here me divided by this is Re cube. Correct now. Re cube divided by Re cube. Now I'll see Re minus d whole square and Re minus d whole square get cancelled. One Re minus d remains. Correct now. Then I'll write this as G of d, GD is equal to GME into Re minus d divided by Re cube is there. Now I'll split it. Okay, I'll write it as Re square into Re square into Re. Why? Because GME by Re square means G on the surface. Correct now. So what happens? GD is equal to G, this is G, correct now, into G into, what is Re by Re? Re by Re is 1. Okay. Minus, what is D by Re? What D by Re is D by Re itself. D by Re. So we got the equation. So G of D is equal to G into 1 minus D by Re. I'll write it here. G of D, variation of G with depth, is equal to G into 1 minus D by Re. What is this G? G is the value of acceleration due to gravity on the surface of Earth. Okay. What does it mean? Say, I'll substitute. If D is equal to Re, if the depth is equal to Re, what does it mean? If the depth becomes equal to radius of Earth, means if you place this mass at the center of the Earth, what happens? If D is equal to Re, Re by Re equal to 1 minus 1 is 0, then what happens? GD will be equal to 0. What does it mean? Acceleration due to gravity at the center of the Earth, at the center of Earth is equal to 0. Acceleration due to gravity at the center of the Earth is equal to 0. So that can be visualized very easily. If you consider a mass here at the center of the Earth, this hemisphere will be attracting this mass upwards. Okay, and this hemisphere will be attracting this mass downwards, and they both have same masses, and this force gets cancelled. Net force on this mass is equal to 0. Force is equal to 0 means acceleration is 0. Acceleration due to gravity is also 0. Okay. Now we will try to solve one problem. Calculate the value, calculate the value of G of Earth at a depth d equal to RE by 2. D is equal to RE by 2. We'll see what happens. So we have the formula solution. We have the formula. GD is equal to G into 1 minus D by RE. Okay. So D is equal to RE by 2. D is equal to RE by 2. So G into 1 minus RE by 2. RE gets cancelled. 1 minus 1 by 2 is 1 by 2. So G into 1 by 2, it becomes G by 2. Okay. You traveled half the distance. You did not reach the center of the earth, but you traveled half the distance. Acceleration due to gravity also becomes half. Means there is a linear variation. What does it mean? If you look at this equation, GD is equal to G minus GD by RE. G minus GD by RE. What is this? This is a constant, correct now? Here, what is variable? This is variable. Now, this equation is in the form of y is equal to c minus mx. This is the equation of straight line. That is why you get answers like this. Means here there is an interesting fact. If we draw variation of acceleration due to gravity with distance, okay. If we draw variation of acceleration due to gravity with the distance from the center of Earth, at the center of Earth, acceleration due to gravity is 0. Okay. As you go up, acceleration due to gravity increases linearly. Okay. And acceleration due to gravity is maximum on the surface of Earth. Then again it decreases like this. Because what is G of H? G of H is equal to Gm divided by Re plus H whole square. Means G, acceleration due to gravity at a height, is inversely proportional to square of the distance. Okay. So this is how the acceleration due to gravity varies with distance. At the center of Earth, acceleration due to gravity is 0. On the surface of Earth, acceleration due to gravity is maximum. Okay. And as you go upwards, again the acceleration due to gravity decreases like this, rectangular hyperbola. Okay. This is how acceleration due to gravity varies with distance. This graph is very, very important. Even the same type of graph comes in electric field chapter. Also it comes in magnetic field chapter. Okay. Every year, either in JEE or NEET, this graph will come either in gravitation chapter, electric field chapter, or in magnetism, because all are fields: electric field, gravitational field, magnetic field. The mathematics related to fields will be almost same only. So if you understand the gravitation chapter very well, if you solve two main problems, then second PUC physics is going to be very, very easy for you. Hope you understood this. Thank you very much.